I am delighted to welcome you to this evening's Eclipse Experience program, a collaborative Zoom series between the Albany Public Library and the Adirondack Experience. I'm Cheryl Bronstein, Director of Interpretation at the Adirondack Experience. I would like to start this evening's program by acknowledging that the Albany Public Library is situated on the land of the Mohawk, Haudenosaunee, and the Stockbridge-Munsee Band of Mohicans. The Adirondack Experience is situated on the Aboriginal territories of the Mohawk and Abenaki communities. Indigenous people continue to live in our two regions and practice their teachings and lifeways. We are less than 20 days away from a phenomenal experience, a total eclipse that will be over the skies of most of the Adirondack region, as well as across much of the country. For those in Albany, you'll have 96% of an eclipse, not quite totality, but enough that you will also see the effects. We hope these programs inspire all of you, no matter where you are joining us from, to safely look up on April 8th. Tonight, I am absolutely thrilled to welcome Dr. Michael West, who is with the Lowell Observatory science team. Michael previously served as director of the Maria Mitchell Observatory, head of science for the European Southern Observatory, head of science operations at Gemini South in Chile, and professor of astronomy at the University of Hawaii. He has also been the principal investigator for 6 Hubble Space Telescope projects. Michael is a recent Fulbright scholar, spending several months in Finland, focusing on science communication with the public. He served on the International Astronomical Union's Commission on Communicating Astronomy with the Public. And where I had the great pleasure of working with him, he served as chief astronomy content developer for the Imiloa Astronomy Center in Hilo, Hawaii. Throughout the evening, please feel free to submit any questions through the Q&A function, not the chat, the Q&A, please, at the bottom of your screen. Michael will take questions as he can during the program and after. Michael?
Great. Thanks so much, Cheryl. And thanks everyone for joining us this evening. Cheryl said, my name is Michael West. I'm an astronomer at Lowell Observatory out in Flagstaff, Arizona. Lowell, if you're not familiar with it, Lowell Observatory is where Pluto was discovered, and it's also where the first observations of the expanding universe were made out here. So what I want to do tonight is just give you an overview of eclipses, encourage you to not miss this one that's coming up on April 8th, and also let you know how to view it safely so that you don't risk damaging your eyes. So I'm just going to talk about 3 different things. First, why do eclipses occur and why only at certain times? I'll talk about eclipses throughout history. People have been observing eclipses for as long as there have been people. And so there have been many attempts to explain the origin of eclipses. And then also there have been many ways that eclipses have influenced human history and cultures around the world. And as I said, at the end, I'll talk about how to safely view this upcoming eclipse. And as Cheryl said, I'm happy to answer any questions as I go along. So let's start with the basics. Why do eclipses occur? And the answer is pretty simple. The moon orbits the Earth, and the Earth orbits the sun. And every once in a while, the moon aligns perfectly between the Earth and sun so that it casts a shadow on the Earth. And this is an eclipse. And those regions where the moon completely blocks the sun's light, we see a total eclipse. Other regions we see, like out here, you'll see a partial eclipse, which is what many people will see, like in the Albany area. Like Cheryl said, it'll be 96 to 97% full. So eclipses don't happen every month. They happen only occasionally when the moon, the sun, and the Earth are lined up perfectly. So total eclipses generally occur somewhere on the Earth, roughly every 18 months or so. But that could be anywhere on the Earth. And don't forget, the Earth's surface is 2/3 water. So most eclipses that ever happen on Earth are seen by nobody, probably. And so it also means that any particular location on Earth, say you're in Albany, is only going to see a total eclipse of the sun roughly every 300 to 400 years. They're very infrequent, occurring at the same spot. Okay, so that's the basic idea behind an eclipse. I'll give you a little bit more information about that. So this is a plot showing the path that eclipses will take across the United States over a 200-year period, from roughly 100 years ago to roughly 100 years from now, right? And so you can see in the orange, for example, this is the path that the eclipse will follow on April 8th. And so it begins down in Mexico, it will go across Texas and make its way up through upstate New York. That's where the total eclipse will occur. A little bit further out, of course, you see parts of the sun covered by the moon. And as you get further away from this path, you see less and less of the sun covered by the moon. This is the eclipse event in 2017. It was visible across this stretch of the United States. I had the pleasure of going to Oregon to see that one. That was pretty amazing. And the one that's coming up in April will be twice as long as the one in 2017. So that's a nice opportunity. Oops, sorry about that. You can see that, there's multiple eclipses coming in the future. Here's one in 2045 that will go across the states. You see that the last total eclipse visible in New York was in almost a century ago, right? It was in 1925. So it is almost a century ago. So, my point is, if you live here, you haven't seen a total eclipse of the sun in at least 200 years or more, right? So Earth isn't the only place that sees eclipses. This is an eclipse visible from Mars. The Perseverance rover spacecraft it images the sun every day with its camera. And what you see going across the face of the sun right now is Mars's moon Phobos. Phobos looks like a potato. It's about 15 miles across. It orbits Mars 3 times a day, and it produces about over 1,000 eclipses each year on Mars. And so the Mars Perseverance spacecraft happened to catch that one in the video. So we're not the only place where you see eclipses, but there are something unique about eclipses on Earth, as I'll talk about. From our perspective here on Earth, the sun and the moon appear to have almost exactly the same size. And so it's a cosmic coincidence, as I'll explain, but this means that from time to time, the moon moves in front of the sun, and it's just the right size to completely block the sun's light. The reason for this is pretty simple. The sun, as you can imagine, is much, much bigger than the moon. It's 400 times bigger than the moon. So, you could line up 400 moons, one after the other, across the equator of the sun. It's much, much bigger. But it's also much, much farther away from us than the moon is. So the moon is smaller, but it's more in our face in a sense. And so that coincidence that the sun is 400 times bigger than the moon, but is also 400 times further away, so it appears 400 times smaller, means that the moon and the sun roughly take up the same amount of space on the sky. That's why we get total eclipses here on Earth. The moon is just the right size to completely block the sun. However, we won't have total eclipses forever. We know that the moon is slowly moving away from the Earth. It moves away from the Earth at a rate of about roughly an inch per year. And so as the moon slowly drifts further and further away, it will appear smaller and smaller in the sky until eventually, someday in the far future, the moon will now appear too small to ever completely block all of the sun's light. It looked like, eventually like that the eclipse on Mars you just saw, a little tiny moon moving in front of the sun. That's what will happen in the Earth someday. It's going to happen in roughly 600 million years, so plan accordingly. As the moon gets farther and farther away, eventually it just won't block all of the sun's light anymore. And we will no longer have total eclipses here on the Earth, but it's well into the future. If you're curious, the reason that the moon is moving away from the Earth is they're exchanging gravitational energy through the tides and things like that. And so the moon is slowly stealing some of the Earth's gravitational energy. It makes our days longer, and it makes the moon move further and further away over time. It's a very gradual process. So the moon, as I said, is just the right size to start blocking the sun. And so the eclipse on April 8th, for example, begins with a piece of the moon slowly starting to move across the face of the sun. And then there are 3 different types of eclipses that occur. One is called a partial eclipse. And again, that's what many people will see. They'll see a big fraction of the sun covered by the moon, but not the whole thing. Why not the whole thing? It's just not aligned perfectly from where you are to see the entire face of the sun blocked out by the moon, but you'll see a big chunk of it. Another kind of eclipse is called an annular eclipse. This occurs because the moon, as it orbits the Earth, is sometimes a little bit closer to the Earth, sometimes a little bit further from the Earth. It's not a perfectly circular orbit. And so sometimes the moon is a little bit further away, and even then it appears too small to block the entire sun's surface. And so you get what's called an annular eclipse. This is annular comes from the Latin word for ring. It looks like a ring. As you mentioned, this is a real photo, actually. This is a wedding proposal that was photographed during an annular eclipse. What's coming up now on April 8th is a total eclipse. And this, as I said, is when the moon completely blocks the sun. And that's when things get really dazzling. During that time, you can see a structure of the sun's way, way outer regions that is called the corona. And it's not visible at any other time because the sun is so bright. All you see is that the bright surface, basically, and you're blinded to all the stuff in the outer parts. But the corona is actually hotter than the surface of the sun. It's millions of degrees. Excuse me. And the corona, interestingly, in the 1800s, two French astronomers during an eclipse like this they analyzed the light coming from the sun, and they realized that the gas in this region of the corona was made of some unknown kind of atom that nobody had ever seen before. And so they called it helium, which comes from helios, meaning the sun. And it turns out this was the atom we call helium today, helium balloons and all that kind of stuff. But helium wasn't discovered on Earth until 27 years later. So it was first discovered in the sun's corona. You can see other features during a total solar eclipse. You see these large outbursts of hot material from the sun. These are called prominences. And so the sun is, it's like a bubbling pot of oatmeal, sort of how it looks like. And occasionally it belches hot material, hot gas out into space. And so we can see that, we can see that during, we can see that during the total eclipse. There we go, as well. There's a phenomenon called Bailey's beads, which you can see during a total eclipse. And this is really cool. So you see these kind of bright, looks like little beads, right? Francis Bailey was an English astronomer. And these beads are actually caused by light from the sun passing through valleys and between the mountains on the moon. And it actually produces this kind of phenomenon right at the very beginning and very end of the total eclipse. It's a really beautiful phenomenon if you ever have a chance to see it. Now, during a total eclipse, the sky gets quite dark, of course. I'll talk more about that. But what it means is if you're in a region where it's truly a total eclipse and the sun's light is sort of completely blocked, you can see planets and other bright stars in the sky sometimes. So for example, this shows what it will look like during the upcoming eclipse on April 8th. And so you see the sun here. Venus is the third brightest object in the sky after the sun and the moon. And so Venus will become visible during totality. Mercury is the planet closest to the sun, so it's usually very hard to see because the sun is so darn bright. But when the sun's light is blocked by the moon, even Mercury should become visible. Jupiter is also a very bright object in the sky, and it should also become visible during the total part of the eclipse. And there's a comet in the sky right now called, well, they always have clever names, 12P Pons Brooks. And in principle, it may be possible to see this during the totality of the eclipse as well, during those roughly 4 minutes when the moon will completely block the sun. That comet may be visible in the sky. So that's something to look out for too during the eclipse. One of the things you'll experience is temperatures really drop. If you're ever out on a hot day and you step into the shade, it feels cooler, right? And that's true during an eclipse. We're basically in the moon's shadow. And so the temperatures can drop by anywhere from 10 to 20 degrees. And you really feel it. I remember when I was at the eclipse in Oregon, it got chilly for a few minutes during the totality of the eclipse. So you definitely will notice that as well. And if you're curious about animal behavior, it turns out that many animals um, exhibit unusual behavior during eclipses. For example, many animals seem to think it's nighttime suddenly, and so they begin their nighttime routine. Uh, Apes, for example, are known to go back into their caves or where their dwellings are in rocks. um, Cows start heading back for the barn. So there's lots of these different behaviors that are observed. It's been observed that some animals grow anxious. So, for example, chimpanzees are known to look up and become more agitated. There's a particular kind of monkey that emits an unusual vocalization that doesn't do it any other time that's ever been observed. So animals seem to react in different ways to the eclipse. In fact, bats will come out because they think it's nighttime, time to start eating insects, all that kind of stuff. So it's very interesting. In fact, if you have animals, if you have pets or near a farm, it's interesting to see how the animals react during the eclipse itself. So, as I said, eclipses don't happen all the time. And so it turns out that this coming April 8th is the last chance to see a total solar eclipse anywhere in the continental US or Canada until 20 years from now. That's why you really don't want to miss this opportunity. It's a great chance to see one of nature's most spectacular shows. So this is the path that the eclipse will follow. And so, as I said, it starts down in Mexico and it will be visible across this stretch of the United States. So here we are, here's Albany right here. This is the path of totality. But again, if you're anywhere near it, you'll still see a big chunk of the sun blocked. In fact, if sorry about that. If you don't mind driving 2 hours north or so, so here's Albany down here. If you don't mind driving north, say to Adirondack Park, for example, you will be able to see the 100% total eclipse. And you might think, what's the difference between 99% and 100%? But it is actually a big difference because it's only when it's 100% covered that you get to see the corona, you get to see all these phenomenal effects, and things get really dark. So it's worth, if you have the time and the inclination, it's worth the drive to get someplace where you can truly see 100% totality, especially since this is the last eclipse. You'll be able to see that way for another 20 years or so. So something to keep in mind. So in the Albany area, the eclipse will begin. That is, the moon will just start passing in front of the sun at about 2:12 in the afternoon. And the maximum eclipse, that's when the moon is most in front of the sun, when everything gets darkest, that will be at around 3:30 in the afternoon. And then the moon will gradually begin to move away from the sun again. And so it will completely be away from the sun at about roughly 4:30 in the afternoon. So again, that's kind of the times you're looking at. But again, the peak, if you can only be out for a few minutes, try to head out around 3:30 or so. That's the best time to see the maximum eclipse. So as I said earlier, eclipses have been, they've influenced history, they've influenced cultures throughout time. And so I just want to give you a few of many, many examples. There's entire books written about eclipses in history, but I'm just going to give you a few examples to illustrate this. So in China, for example, in ancient China, it was believed that eclipses occur because a dragon is eating the sun. Dragons breathe fire, they love fire, and the sun is a big ball of fire in the sky, essentially. And so, in fact, the Mandarin word for eclipse is shi, which means to eat. So in ancient China, they thought a dragon was eating the sun. In fact, this was considered a bad omen for obvious reasons. So there's a famous story. There were two ancient Chinese astronomers who failed to predict an eclipse. An eclipse happened and nobody had known it was coming. And these two astronomers were executed because they hadn't let people know that an eclipse was coming. Yeah, even ancient astronomers were very good at predicting when eclipses would occur because they had a historical record. They knew that there was a pattern to when eclipses happen and when they don't. And so the argument was these Chinese astronomers should have known an eclipse was coming. The fact that they didn't, they were executed for that. In Benin, in Western Africa, the Bataramimba people uh, believe that eclipses occur because conflict between human beings on Earth and fighting between human beings on Earth has spread to the sun and the moon. And so the sun and the moon are now fighting. That's why the eclipse is occurring. And the only way to solve this, to bring the sun and the moon back, is for people to get together and to resolve their conflicts. And so during an eclipse, it's a time for a community to gather and everyone to make peace with one another, basically. That's the only way to save the sun during an eclipse. In India, there's a Hindu legend about Rahu. And Rahu was a demon who stole immortality from the gods. But the sun and the moon saw this demon doing it and reported him to Vishnu, one of the gods. And Vishnu, it's a little gory, cut his head off, and his head now chases the moon and the sun through the sky. Because he'd taken some of this potion of immortality, his head lives forever. But because his head was removed from his body, he has no body, no throat, no stomach. So when he swallows the sun always comes out again at the end. Even today in India, there are many people that think they fast, they don't eat during a total eclipse of the sun because they believe any food prepared during a total eclipse is unpure and potentially dangerous. So these are just some of many different ways that people all around the world have tried to explain eclipses all throughout time. Here's a famous historical example. In May 585 BC, there was a war going on in what's modern day Turkey now. And it was a war between the Lydians and the Medes. And they've been fighting for years and years and years. And there's a massive battle going on when suddenly the moon blotted out the sky and everything started to get dark. And so the soldiers and their leaders thought that this was an omen. This was a sign from the heavens that they should stop fighting. And so they did. They stopped fighting and they went on to create a peace treaty that held after that. So this is one of those examples where human history was influenced by a natural event. In this case, the eclipse of the sun. It stopped a war. This is the first photograph that was ever taken of a solar eclipse. This is from 1851. It was a scientist in Russia, what's modern day Russia, who took a photograph of the sun for the first time. This is actually a daguerreotype. It's a early primitive photography. This is the first video of a solar eclipse. This is from 1900. This was a magician, actually, who shot this film. And so you can see the moon moving in front of the sun. Now you see totality. You can start to see the corona around the sun as well. And then eventually the moon will go past it again. But so not bad, right? This is, 124 years ago, basically. Pretty cool. So you might not know, an eclipse also played a key role in Albert Einstein's work. I already said earlier, scientifically, the atom helium was discovered during a solar eclipse. Well, a solar eclipse also proved that Einstein was right. Einstein had this theory that he called his general theory of relativity, and it's just a fancy word for gravity. Einstein's theory tries to explain how gravity works. We think of gravity as an attraction between two different objects. But Einstein said, I think even light should be attracted by a massive object. And that seemed crazy at the time because light doesn't have any mass. It doesn't weigh anything. But Einstein made a prediction. He said, during a total eclipse of the sun, light will get deflected by the sun's gravitational tug. So let's say you have a star here, and this light would normally just keep going in a nice straight line. The light travels straight. But because it passes near the sun's gravity deflects it, it bends it. And so we see it here on Earth. And from our perspective, as we look up, we see the star as if it appeared here. So the position of the star in the sky is different from what its true position is. So Einstein said, well, here's a test of my theory of gravity. My theory of gravity, which I call the general theory of relativity, predicts that the sun and its gravity should be able to bend the path of light and make the stars appear in different positions. And so there was a famous expedition in 1919 that went to watch an eclipse off of the coast of West Africa and down in Brazil. And they actually took photographs, and you can see all these little yellow circles are the positions of stars. And when they compared the positions of those stars with their known positions when the sun's not in the way, they were slightly different. And so that slight difference was because the sun's gravity had bent the light rays and made the stars appear in slightly different positions than they should be, right? And it's a tiny amount, right? If you took a quarter and somebody held it 2 miles away, so imagine how tiny that quarter would look, the amount the stars' positions changed on the sky during the eclipse of the sun was less than the width of that quarter when seen from 2 miles away. So it's a tiny amount, but scientists can measure it. And so this showed that Einstein was right. His general theory of relativity was a good description of the way gravity works. And he became world famous after that. This eclipse sort of confirmed Einstein's theory, and he became a celebrity after that. All right, so let me finish up by talking about how you can view the upcoming eclipse safely. And the first thing I really, really want to emphasize is don't ever look at an eclipse without eclipse glasses. And you shouldn't look at the sun without eclipse glasses. And you might think, well, even if the sun is 99% covered, surely that should be safe for me to look at the sun. And the answer is no, because even just a little sliver of sunlight is still so bright that if you stare at it, it can damage your eyes, right? And so before you know it, as you stare at an eclipse, you can permanently damage your retinas, right? And so you have to be really, really, there's scientific studies show, for example, that you only have to look at the direct sun for about a minute to produce damage to your retinas, okay? And there, if you Google it, if you go online, you will find lots of sad stories of people that lost their eyesight because they stared at an eclipse, right? So just never look at an eclipse without eclipse glasses. I can't emphasize that enough. Why does that happen? Well, if you think about it, here's the eclipse. Here's your eye. Your eye has a lens, right? Well, think of like a magnifying glass. Have you ever used a magnifying glass to burn something by concentrating the sun's rays of light? Well, that's what you're doing to your eye, essentially. Your lens concentrates the sunlight to your retina, where the image is produced, and it's so intense, it's going to burn your retina. And you can never recover from that, and you can be blind or partially blind as a result. That's why it's important to wear eclipse glasses. Eclipse glasses are just really, really dark lenses, much darker than regular sunglasses, and they block 99.99% of the sun's light from getting through. You can still see the sun, but it blocks almost all of its light, and it blocks not only the visible light, but the ultraviolet and the infrared light, which can both do major damage to your eyes. So that's why you want to wear these things. Now, if you haven't bought eclipse glasses already, I believe the Albany Public Library is making them available for free. You can also order them online. I just sent them to my brother in Vermont from Amazon. So you can find them lots of places, but you only want to use eclipse glasses that are officially designated as safe. And that means they have a label on them that says ISO and then this number 12312. That means that they're approved for looking at the sun with. The lens material is so dark and so thick that your eyes are safe when you look at the sun. So it's really important. Make sure, don't just get any eclipse glasses, get safe eclipse glasses, but you can easily find them online. Or again, as I said, the Albany Public Library will be making them available for free as well. If you're in doubt, the American Astronomical Society, has a good webpage that lists all the manufacturers of eclipse glasses that they deem are safe to use. So if you remember nothing else, American Astronomical Society, if you go there, their webpage will tell you all sorts of information about the eclipse, including safe glasses to buy. So again, the way these things work is they're just really, really dark. They're like 10,000 times darker than regular sunglasses. And so it blocks almost all of the sun's light from getting through, but a little bit does. And that allows you to see the eclipse as it happens and to protect your eyes. So yes, you always want to wear eclipse glasses during an eclipse. Your regular sunglasses will not work. They just don't block enough of the sunlight. So in particular, they don't block the ultraviolet and the infrared, which will really damage your retina. So don't think that regular sunglasses are adequate. They're not. It'll still damage your eyes. Likewise, sometimes people think, if I'm wearing eclipse glasses, can I then look through my camera, or can I then look through with binoculars at the eclipse or something? And the answer is no, because the light that gets concentrated through your camera lens, or when you're looking, even if you put your solar eclipse glasses, the light is so intense through your camera lens, it will burn a hole in the filter in your eclipse glasses, and it will still damage your eye. So yes, always wear eclipse glasses to look at an eclipse or to look at the sun, but don't ever do that even through a camera lens or binoculars, because it's not safe. Again, I'm sorry to keep harping on this, but I just want to make sure everybody does this safely. You know, if you have kids who are going to watch the eclipse, you just be really careful to make sure that their eclipse glasses are on safely. They don't take them off, all that kind of thing. It doesn't take long to damage your eyes. So again, if you wear eclipse glasses, it's perfectly safe to look at the eclipse. There'd be no problem. And again, this will be an amazing experience, when it won't happen again for another 20 years. If you don't have eclipse glasses, another thing that you can do is take a colander, that you drain your spaghetti in, and bring it outside in the sun, and hold it up so it casts a shadow on the ground. And what's happening is all the little holes in your colander, they're acting like little individual pinhole cameras, and they project an image of the sun on the ground. And in those little images, you can see the eclipse. In this case, you can see the moon starting to block some of the sun's light. So again, you don't hold the colander up and look at the sun. You let it cast a shadow onto the ground, and that allows you to see the eclipse without needing eclipse glasses and without risking harm to your eyes. You have to adjust the height so that you get everything into focus, but it works really well. Also, if it is cloudy, which is not a negligible probability in the Albany region, if it's cloudy, NASA is actually live streaming the eclipse all across the country. They've lined up a series of telescopes all along the path that will be showing images of the eclipse as it happens. And so you can stream those, you can watch those on NASA, tuning in at any time. Again, the eclipse starts sort of in the morning hours down in Texas, and then late in the afternoon up in upstate New York, and then eventually into Montreal and all those places as well. So that's all I wanted to say. I just encourage everybody, again, this is your opportunity to see one of nature's most spectacular shows. And so don't miss this opportunity. I hope it's clear skies there. Here in Flagstaff, where I live, the sun's only going to be covered, the moon's going to cover the sun only 68%. So it's not going to be, it'll still be really cool, don't get me wrong, but it's not the same thing as being able to see a total eclipse. And so if you have the time and energy to drive 2 hours north to see the total eclipse, it really is a whole different experience. That said, a 97% eclipse is still a really amazing experience. So that's all I have to say. I'm happy to answer any questions if anybody has any. I just wanted to say a quick thanks to the Adirondack Experience and the Albany Public Library for inviting me to speak tonight. And if you have any questions, my email address is down here. Again, I'm Michael West at Lowell Observatory. Just drop me a line, send me an email, and I'm happy to answer any questions you might have about the eclipse or astronomy in general. So anyway, so that's all I have to say. I'm happy to answer any questions.
Michael, we've had a lot of questions come in, and I do want to. There's a few that came in through the chat as well as through the Q&A. So I'm going to go ahead and flag a few of these, and hopefully we've got some time to address them. So one person actually wanted to see the map that you showed earlier of the planets. If you can scroll back to that, and maybe talk a little bit more about that one. And then a lot of the questions that came in also had to do with people viewing. How does kind of home remedies on how to view. So let me have you walk us through this again, and then I'll pick up on some of the other questions that have come up.
So again, normally, I mean, anytime the sun is in the sky, Mercury and Venus aren't far away from it because they're the two planets that orbit closest to the sun. But we can't see them because the sun is just so bright. But during an eclipse, the sun's not so bright anymore. And so Mercury and Venus can become visible. This is really true only if you're in the path totality, if the moon is blocking the sun 100%. Then, I mean, actually, that said, if you knew where to look right now on a sunny day, you can see Venus in the daytime sky. You just need to know where to look. It's that bright, actually. So during the eclipse, especially during totality, Venus and Mercury should become visible. Jupiter is also a very bright object in the sky, and it should also be visible. Uranus is way too faint to see. It's just really faint, so you'll never see that. And then there's this new comet that is appearing in the sky now. You can see it. I forget if it's the early evening now. I don't remember. But it'll be hanging around in the sky still as it goes around the sun during the eclipse on April 8th. And so as the sky gets dark during the moon blocking the sun, you will be able to see, hopefully you'll be able to see this comet. It sort of depends on, comets change in brightness a lot over time. And so as it's getting near the sun, it may flare up in brightness, which would make it easier to see, or it might not, which will make it harder to see. But at least it's a possibility. It's not every day there's a comet visible in the sky during an eclipse. So I hope that answers the questions. If you really want to see these things, like I keep saying, you should always look at an eclipse with eclipse glasses. But if, and this is a big if you're in a place where it's a total 100% eclipse, then there'll be a few minutes where suddenly you can't see the sun through your eclipse glasses anymore. And that's because the moon has completely blocked its light. That's the only time it's safe to take your glasses off for those 3 or 4 minutes. And then you'd be able to see the planets and maybe the comet around it. You'll never see the comet, for example, through your eclipse glasses because it's just too faint still to be seen that way. So you would have to take them off, and again, only do that during the maximum 100% eclipse period. So I hope that answered the question.
We'll let you know because there's a lot more coming in. So several people have asked, and I'm going to kind of jumble these together and maybe have you walk us through it. But people have asked if they can use Mylar film in front of glasses, regular glasses, VHS film tape, floppy disk tape as well, to try to maybe make their own glasses. People also wanted to know, how do you safely look through binoculars or a telescope? Like, how do you do that with your the eclipse glasses? And then do you put your eyeglasses on over the eclipse glasses or vice versa?
That's always a good question. So I mean, it's making your own homemade glasses is possible, but it's just risky. Like I would not use, VHS film or anything like that. It's just not dark enough. It's just not opaque enough. Mylar is sometimes used for what are called solar filters on telescopes. And so you can put Mylar in front of a telescope if it's of sufficient quality to block the sun's light safely and let you look through it. So for example, you can buy filters for your telescope that's a solar filter, and sometimes they're made from Mylar, and that can be a safe way to look at the sun. But in general, I mean, again, my advice is if you can get a free pair of eclipse glasses, or even just buy them, they're not expensive at all. It's just a good way to make sure that you've got 100% safety. I personally wouldn't, it's just me, but I'd be very wary about trying to make my own, do-it-yourself eclipse glasses, that if I make a mistake, I'm going to be, blind for the rest of my life or something. So I think that's, I forget what the other questions were, Cheryl, sorry.
It's okay. People were just again asking about glasses, like which.
Oh yeah, that's right. Yeah, so I don't know. People often ask that about the. I don't think it actually makes a difference. I would personally, I wear glasses. I would still wear my eclipse glasses over my regular glasses. But to be honest, I don't really think it matters, because your regular glasses don't concentrate the light that much like a camera lens or a telescope would, or anything like that. So yeah, anyway, I hope. Oh, and so to make your own, I mean, if you want to look through binoculars or look through a telescope at the eclipse, you need a solar filter. You can get solar filters for binoculars even. You need something that's going to drop the light of the sun by 99.99%. And you can buy these online. You can even buy them on Amazon. You can buy them from, a bunch of places online. But if you want to look through binoculars, in fact, I have a pair of eclipse binoculars I bought for the 2017 eclipse. And again, they have those special filters. So it's, if you don't mind spending the money, I don't remember how much they were. It's a really cool way to look at an eclipse, because you do get the magnification then and everything, and that's pretty cool. But again, these are, these binoculars I bought are made by a well-respected company that makes solar telescopes and things like that. So they're safe for sure.
Just to change direction a little bit on questions, there's a lot that came in about, again, the safe look viewing. But a couple people had some questions related to some of the other topics that you covered. So one person asks, why do the eclipse paths move in different directions when the sun always rises in the east and sets in the west?
Yeah, that's a great question. It all has to do with how things line up. No pun intended. Um, the Earth and the Sun and the Moon are a triple system, and the Moon is going around the Earth, and the Earth is going around the Sun. But even during an eclipse, the Moon is also moving in its orbit around the Earth, and so it's the way things align that determines on any given day and any given location where an eclipse will be visible and in what direction it will move. So that's that's basically the short answer. One of the questions people often ask is, why don't we have an eclipse every month? Right? We know the moon goes around the sun once a month, so shouldn't it? Sorry, the moon goes around the Earth once a month, so shouldn't it block the sun once a month? And the answer is no, because the moon's orbit, it's wobbly a little bit. So sometimes, only rarely, does it line up just right to block the sun's light. Most of the time it doesn't. And so that's why you can get eclipses seem to travel in different directions, from north to south, or south to from west to east, or whatever. It depends on the specific way that the sun and the moon and the earth are lined up at that particular time.
Thanks. Someone asked, will anyone like NASA or other observatories be filming the eclipse for research study later?
Yeah, somebody asked me if I was planning to film it, because she does video documentaries, but I wasn't planning on it. But yeah, sure. I mean, and the thing too is, in the old days, I talked about the corona before. That's this really extended part of the sun that we didn't even know existed until eclipses. And nowadays, astronomers are not the cleverest people in the world, but one astronomer someday said, why do we have to wait for eclipses for the moon to block the sun all the time? Can't we just put a little piece of cardboard in front of the sun and block its light? And everybody applauded and said, that's a great idea. And they named it a coronagraph. And so now we have these instruments called coronagraphs that can block the light of the sun anytime we want, and let us see the outer structures like that. So I'm sure NASA will be recording this, and again, they'll probably show the videos on the NASA website, I imagine. But they can also they can make eclipses whenever they want these days, basically, to study the sun's structure.
Well, I do have to say, I think you're a pretty smart guy, Michael. So I love this question because I think it's a perfect blend of, from a history museum talking to a scientist. At what point in history do they begin predicting eclipses, and how do they predict where they would be?
So that's a really good question. So the earliest recorded eclipse, I believe, is from like, was it 1300 BCE or something? I don't quote me on that, but it goes back a long ways. And humans are great watchers of the sky, and so people began to notice over long periods of time, longer than a human lifetime, that there were certain patterns in where and when and how eclipses happen. There's something that's called the Saros cycle, for example, and it's this realization that eclipses occur at certain times in certain places, and then they repeat again as well, sort of. And so, through historical records, going back thousands of years now, humans began to realize, on such and such a date, there was an eclipse here, and realizing that, well, it's likely to repeat again on this other date in the future. And that's how they're able to predict things. It's actually really remarkable. Today, astronomers, we can calculate the moon's orbit really precisely, within inches. And we can, figure out, to the minute when the eclipse is going to happen on April 8th. But going back thousands of years, and people didn't have that. I mean, heck, they didn't even know what the moon or the sun were compared to the Earth. And yet they were still able to predict eclipses with quite good precision, just because they started to recognize patterns in where and when eclipses occurred over long periods of time. But it's a great human achievement to be able to do these things. And again, it just shows how observant humans are, how we really are good at picking up things.
Another question going back to kind of the history of science. Somebody wanted a little bit more information about how do they find helium at the sun?
Okay, great question. So if you take sunlight and you shine it through a prism, you get the colors of the rainbow, right? But if you looked really close at the magnifying glass, you'd see that in those colors of the rainbow from the sunlight, there are a few dark lines where the light is missing. And that light is missing at specific colors because atoms of different types absorb that light. So for example, if I want to figure out what a Twinkie's made of, one way I can do it is I can vaporize the Twinkie into a gas and shine light through it. And I'll see the colors of the rainbow coming through my prism, but there'll be certain colors are missing. And those colors of light were absorbed by the different types of atoms that make up my Twinkie. That's probably a terrible analogy. And so by looking at the light coming from the sun's corona through a prism, they said, oh, that dark line, I know that comes from carbon. I know that dark line comes from oxygen. I have no idea what that dark line comes from, what kind of atoms produce that. And it turns out they named it helium, and it was discovered on Earth, 3 decades later. But that's how you do it. It's called spectroscopy. If you Google it, spectroscopy or spectroscopy is the way they did it. And this is in, I think it was like 1871 or something. It was 2 French astronomers who did this.
Thank you. So again, a question in a different direction. What apps and computer programs can be used to illustrate the real-time positions of celestial bodies in the human solar system?
Oh, that's a great one. I have an app on my phone. I forget what it's called. But NASA's got an app, I think, even for the eclipse coming up. Let me see. The one I use is called, hang on, I'm just looking for it really quick. Sky Guide is one I like. So I'm an astronomer. I'm embarrassingly bad at the constellations and stuff. So when everybody says, somebody says, what's that star? What's that constellation? I have no idea, but I whip out my phone and I hold it up and it shows me everything that's visible in the sky where my phone is pointing. So I use one called Sky Guide, but there's a bunch of those different things. So that you can find tons of these apps out there. Also, there's websites. There's ones, for example, I can't remember the name at the moment, but you can actually find out like when is the International Space Station going to pass over your head, and you can actually go out and look at it. I've seen it many times. It says, well, it's going to pass over my home tonight at 9 o'clock p.m. I go out there, and sure enough, you can see it going across the sky. So there's all sorts of different things you can get like that. But check out NASA. NASA's got some apps of their own that are usually pretty good.
Okay. Somebody said, how long would the eclipse last from all the way south to all the way north? How many minutes in totality? I'm not sure
Question.
if
Let me look at
it's.
so let's see. Oops. I had a map that I think showed the different times. Here we go. So this shows sort of at the bottom, starting at like, noonish Central Standard Time, or yeah, oh, that's in Mexico. In the States, it'll be yeah, like 1:30 in the afternoon Central Daylight Time up till like sort of 4 o'clock-ish when you get up into uh, Upper Maine and New Brunswick and that kind of thing. So I mean, the whole thing will last a period of like 3 or 4 hours basically. But again, the totality, when the moon completely blocks the sun, that will last for about 3.5 to 4 minutes in most places. And again, when I saw the eclipse in 2017, it lasted only 2 minutes. I would have wished it could have lasted longer because it was such an amazing experience. So this is a good opportunity to see a longer total solar eclipse this time.
Somebody asked if it's cloudy, will it still get dark? The way,
Great,
like as dark as night.
great question. It never gets as dark as night. It's like dusk. It's like that's why it's like, if you go out, it's as it's getting dusk, you can kind of see Venus on the horizon sometimes and that sort of thing. But it doesn't get as dark as night, but it gets darker. It gets like twilight basically. Um, and so sorry, what was the question again? I went off on a tangent.
Would it'll if it's cloudy, will it be
Yeah,
as
yeah.
dark?
So yes, it will still get noticeably darker even if it's cloudy because, even on a cloudy day, it's bright outside because the sunlight is shining through. And so now if you block the light of the sun with the moon, it's still going to start to get darker as well. Might be less dramatic because the clouds will diffuse the light, but it will definitely get darker.
And somebody wanted to ask if you could explain the colander, using the colander again.
Sure. So if you have a colander at home, like I got a cheap plastic one for braining spaghetti, but if you have a metal one, um, anything with little tiny holes, it's like if you're familiar with pinhole cameras, like if you ever made a shoebox camera when you were in school, you take a shoebox, you poke a pinhole in it, and then you put film in the back, and it records an image. It's a little tiny pupil, that little pinhole, and that's essentially what your colander is doing. You put it outside and the sunlight passes through not one pinhole, but many pinholes. All the holes in your colander become like little individual pinholes or lenses, and they produce an image of the sun on the ground below it. And so what you do is you take your colander, and like I said, don't hold it up to the sun, but let it project the sun's light through it onto the ground. And then you have to adjust it, just like with a camera, you have to bring it into focus. Your lens has to move in and out a little bit to focus. You have to do that with a colander. You move it a little bit up or a little bit down until it's focusing the light to make a sharp image on the ground. And that will let you see um, the eclipse as it happens. It's a super inexpensive way to do it. And you can argue it's maybe safer for children because they're not messing around with eclipse glasses and trying to look directly at the sun. It's a very indirect way that a group of people can watch it at the same time.
Great. So again, going back to some of the history of science, what other discoveries could be made during a total solar eclipse?
Great question. It's hard to predict, right? I mean, we're still learning a lot about the sun. The sun is really complex, actually, and so you know, being able to see features on the sun that you might not see any other time, things like that are opportunities that can come during an eclipse. But it's sort of hard to predict what's the unpredictable or what's the unknown about the sun. Even like why does the sun have sunspots, or why do sunspots the number change over a period of 11 years? Okay, we think we have a pretty good idea of what's going on, but we don't know for sure. And so eclipses. So one of the big mysteries is the corona I talked about. Uh, this really outer region of the sun where the temperature is millions of degrees. So normally, if you're standing near a campfire, it gets hot, but if you move further away, the temperature falls off pretty quick. It gets cooler much quicker. So why is region of the sun that's farther away, much hotter than the surface of the sun that we see. That's a mystery that astronomers, again, there's never a shortage of suggestions, but we don't know for sure the answer at the moment, though we have several ideas about it. So being able to study the corona like that is an opportunity to maybe figure out what's going on and what is the energy source that heats up the corona to such high temperatures.
I think you've got a lifetime of discoveries and wonder ahead of
I'll
you.
never be unemployed.
Um, so I'm not sure if you would know this or not. Somebody was asking about welding glasses and if you can use
I,
welding glasses
I
or what
believe
kind.
I believe you can actually use welding glasses. I've never seen that much about it, but they're so good at protecting your eyes, right? Because you know the during welding, the arc, the flames can also be so bright that it can damage your eyes. So don't research this. Check for yourself because I'm not an authority, but I think it is possible to use welding glasses. But again, don't quote me on that.
All right, and I'm gonna we'll take a couple more questions. I am a little bit mindful of the time, but somebody was wondering when did people first realize that looking at an eclipse could damage one's eyes?
Oh, that's a really good question. I'm not sure, but I bet there are a lot of ancient people that ended up blinded because of this. The thing is, it's really hard to know you're damaging your eyes because your retina doesn't have any um, pain sensors. So you can be cooking your eyes by looking into sun. You can be cooking your eyes by looking at an eclipse, and it doesn't hurt, right? But if you ever like stare into like really bright car lights or something, and then you look away, you still see like the glow or something in your eyes. And that's kind of when you realize you've damaged your eyes by looking at the sun or looking during an eclipse. Because suddenly when you look away, you still see bright spots. That's because you burned your retinas. If you burn your hand over a flame, your nerves say, whoops, that's not a good idea, and you pull your hand away. But your eyes can't do that. And so you're just burning out your retinas before you know it. And so I imagine that going back historically, ever since people started looking at eclipses, sadly, there must have been people that ended up blind or partially blind just from damaging their eyes by looking at it. But I don't know when the first one was, but I would suspect as soon as there were people and eclipses, there were unfortunately some blind people.
Um, somebody wants to know where you're going to watch the eclipse.
I'm staying here, unfortunately. But yeah, I'll get to see 68%. We had a partial eclipse here a few months ago too. So I sat outside and watched that. But I went to the 2017 one in Oregon. But now with like work and everything, I'm not going to go anywhere. But there are people that once they see a total eclipse, they get they become eclipse chasers, it's called. They get the bug and they go all around the world. Oh, the next eclipse is in Mongolia. Great, let's go. Or the next one's in Antarctica. Awesome. And so they travel the world just to see the next eclipse. It just becomes a passion for them. But yeah, I'm just staying in Flagstaff, 68% coverage.
Well, that should still be impressive as you've
Yeah,
explained.
it will be for sure. But that's why, again, if anybody who's in the Albany area can drive 2 hours or so north to the total eclipse path, it really is worth the difference because that 1 or 2% when everything truly is covered is makes a big difference.
Let's see. I'm going to bring up one more question, and I think we'll have to follow up with some of these separately. But somebody was asking about pets and whether or not they should close the windows of their house.
No, I don't think so. I have a dog. He's right here, actually. And no matter how hard I try, I can never get him to look up at the starry sky at night. Here in Flagstaff, I can see the Milky Way when I go out at night. We're a dark sky city, and it's you're if you have a cat or dog at home, they won't naturally look up at the sun or anything like that. So I don't think you need to worry about it. And they're not the kind to stare at it anyway, I think. So I don't think you need to really worry about that with pets. I'd be happy if I could get my dog to look up at the moon one of these years, but there's no interest.
All right. Well, thank you. I know that there was a few questions about filming and cameras. I do want to shout out a plug for the program that we hosted 2 weeks ago that was really focused on photographing eclipses. I know that right now we're working on the link on the ADKX website for that past program, but I'll just encourage everybody to look at that to get some more information. And I think in the chat, there's been a lot of reference information as well for photographing and filming the eclipses and different safety tips. So I do want to thank everybody for joining us this evening. I want to thank Michael. This has been absolutely fantastic. And I also want to recognize Amy McLaughlin from Albany Public Library, who has helped to bring these programs to all of you. And as I mentioned, we are recording this program. It should be available on the ADKX website and through the Albany Public Library in the next couple of days. And I did want to let everybody know that we've got one more program in this series on April 3rd. It's the last program in this Zoom series. And this is our annual feature of Chef Kevin McCarthy and the students from Paul Smith's College Culinary and Hospitality Program. And yes, we actually are still connecting to the Eclipse. They've got a special themed menu that they will be presenting to match with this once-in-a-lifetime experience. So Michael, thank you so much. It was wonderful to see you, a fabulous program, and thanks to all of you for watching. So good night, everybody.
All right, thanks for all your great questions too.
Thanks. Bye-bye.